Hello friends, in this video we are going to learn how if-else statement can be used in programming Arduino. Let's start an example in Arduino IDE that uses if-else statement and a software counter to turn on or off the LEDs. In the setup function, I'm gonna set mode of pin 8, 9 and 10 to output. We'll also set up serial communication because we'll need this later to see the status of LEDs. After setting up the configurations that we need, we can directly jump over to loop function. In this function, we can write our main function. I'm introducing the LED counter to turn on or off LEDs. Where loop function gets called, this counter gets incremented by 1. To be specific, I'm using two arithmetic operators, which are assignment operator and addition operator to raise this counter. Let's begin with if statement. If LED counter is equal to 1, then I'm going to use digital write API to set pin 8 to high. Setting this pin to high will turn on the LED connected to it. Digital write API needs two input parameters. First parameter is the pin number and second parameter is the required output state for the pin number given as first parameter. I want to print this information to serial monitor and I'm using print API to write this information. In this case, red LED is connected to pin 8. If you are not sure how serial printing in Arduino works, then stay tuned. You will get to know in one of my next videos. I want to stop the software for 500 milliseconds so that the red LED stays turned on for at least 500 milliseconds. If the first statement is not true, the software will jump over to the second statement. In a case where LED counter is equal to 2, I'm gonna use digital write API to set pin 9 to high. That will turn on the LED connected to it. I'm gonna provide this API pin 9 as its first parameter and required output state as high its second parameter. As I have done in my previous statement, I want to write this information to serial monitor. I'll use print API and write the respective information in it. Whatever we will write here will be displayed on serial monitor and we will see that once we run the software. Again, I want to put a delay of 500 milliseconds. If both of the above statements are false, then else will always be executed. In else case, I set the pin 10 to high and that will turn on the LED connected to it. In this case, it is the green LED and I am using print API to show it on serial monitor. And as I have explained before, to display our required information, we use quotation marks to start and to end our statement. To let this LED stay turned on for at least 500 milliseconds, I'm using a delay API. To turn on the LEDs again once the LEDs are turned off, the LED counter must be set to 0. In the second part of this else case, I'll turn off all three LEDs connected to pin 8, 9 and 10 by setting their output status to low. The best practice of writing software is always to add necessary information inside the code in the form of comments. I have not added many comments in this software, otherwise this video length would have been too long. To turn off the LEDs, I'm using digital write API with pin number of LEDs and required output state of LED. I'm being a bit lazy here and copying this line of code and use it for pin 9 and pin 10 to set their output state to low. All LEDs have to be turned off at least for the time that can be experienced and I'm setting it to 500 milliseconds. Code writing is done. Now I need to compile this code. In the toolbar buttons, press verify. That will start checking the software for errors and then it will compile it. I just realized that I have not added the interface to print information on serial monitor once all LEDs are switched off. I'm adding this interface with respective information. This additional information will change the software. Compilation and error checking will be necessary after this change. To compile the software again, press the verify button. After successful compilation, we will upload this software to Arduino board. We see that the red LED is getting turned on first, then the blue LED and then at the end the green LED. After the green LED turns on for 500 milliseconds, all LEDs get turned off. Right after 500 milliseconds, the cycle starts again with red LED. If we read serial monitor, we see that all LEDs are getting turned on and off cyclically.